Sixth-generation fighter jets represent the next major leap in air combat technology. These jets are not just upgrades, they are a complete reimagining of what a fighter aircraft can be. They are being designed for operations in the highly complex and challenging battlefields of the future, well beyond the year 2040. Their main goal is to guarantee air superiority against the most advanced threats imaginable. This goes far beyond just speed and stealth. It includes the ability to process massive amounts of data, control swarms of drones, and dominate the electromagnetic spectrum. They are designed to serve as the central command node in a network of interconnected systems, both in the air and on the ground. The importance of this new generation cannot be overstated. As potential adversaries develop advanced fifth-generation systems and anti-access or area denial capabilities, current aircraft like the F-22 and F-35 will eventually face new challenges. Sixth-generation fighters are the answer to this evolving threat landscape. They are being built on the assumption that the future of warfare will be data-driven. Victory will go to the side that can gather, process, and act on information faster and more effectively than the opponent. These new jets are the key to achieving this information advantage, making them a vital part of future military strategy for any global power. These aircraft are often described as systems of systems. This means the jet itself is just one part of a much larger, integrated network. The aircraft will work seamlessly with satellites, unmanned aerial vehicles, ground forces, and naval assets. The pilot, who may or may not be physically inside the cockpit, will act more like a mission commander or battle manager than a traditional pilot. This optionally manned concept is a core feature, allowing missions that are too long or too dangerous for a human pilot. The entire platform is built around software, making it highly adaptable and upgradable for decades to come. Ultimately, the goal of the sixth-generation fighter is to achieve decision superiority. In a future conflict, the window for making a critical decision might be just a few seconds. These jets will use artificial intelligence and advanced computing to provide the pilot with the best possible options in real time. They will be able to see the battlefield with unmatched clarity, merging countless sensor feeds into a single, understandable picture. This allows them to anticipate enemy actions, neutralize threats before they happen, and control the speed and outcome of an engagement. They are not just warplanes, they are flying supercomputers, designed for ultimate control of the skies. The jump from fifth-generation to sixth-generation fighters is even more important than the jump from fourth-generation to fifth-generation. Fifth-generation jets, like the F-35, brought in stealth and sensor fusion as their main features. They were made to be mostly invisible to enemy radar and give the pilot a full view of what's around them. Sixth-generation ideas take these concepts much further. While they will still be very stealthy, their focus shifts from just being hard to see to actively controlling the whole electromagnetic spectrum. This includes not just radar, but also communications and electronic signals, turning the jet into a powerful tool for electronic warfare. Another big difference is in how they'll be used. Fourth-generation fighters, like the F-15 or Su-27, were made for dogfights and specific attack missions, often flying in big groups. Fifth-generation jets fly more on their own, using their stealth to get into enemy airspace. Sixth-generation fighters will lead and control groups of unmanned, loyal wingman drones. These smaller robot planes will fly next to the main fighter, making its sensors reach further, carrying extra weapons, and even sacrificing themselves to protect the piloted aircraft. This way of working together changes air combat a lot, making a fighting force that can adapt better and do more things. The way the aircraft itself is built is also changing. Many sixth-generation designs have no tail or are shaped like a flying wing. This is to make them as stealthy as possible at all frequencies, especially against low-frequency radars that can sometimes spot current stealth planes. Also, the inside systems are built on an open mission systems design. This is a big change from older generations, where the hardware and software were tightly connected and hard to update. An open design allows for quick and cheap updates with new software and hardware, much like a smartphone, making sure the aircraft stays up to date with technology for its whole life. Finally, the pilot's job is changing too. In fourth-generation jets, the pilot was busy managing many different systems. Generation simplified this with sensor fusion. Sixth generation aims to lower the pilot's workload even more with advanced AI and automation. The AI will handle many complex tasks of flying the plane, managing the drone group, and running the electronic warfare systems. This frees up the human pilot to focus on big-picture strategy and making important decisions that machines can't. For some missions, the pilot might not even be in the cockpit at all, with the plane flying completely on its own or being controlled from the ground. One of the most important technologies for sixth-generation fighters is the adaptive cycle engine. Current jet engines are designed to be good at either subsonic speeds, like a passenger plane's turbofan, or supersonic speeds, like a traditional turbojet. They can't do both well. Adaptive cycle engines, like those being developed under the U.S. Air Force's Adaptive Engine Transition Program, can change their inside setup while flying. This lets them act like a high-bypass turbofan for better fuel use and longer range when cruising, and then switch to a high-performance turbojet for maximum power and speed in a fight. This big step forward gives a huge boost in range and how long the plane can stay in the air. Advanced electronic warfare systems are another key part of this new type of aircraft. These fighters won't just mess up enemy radar. They'll be able to trick, confuse, and disable enemy sensors and networks. By using strong active phased array radars, they can pick up enemy signals, figure them out, and then send out wrong information, making it look like there are ghost fleets or showing the fighter in a different place. This ability to control the electromagnetic spectrum turns the aircraft into a ghost on the battlefield. It can also use its powerful electronic systems to launch cyber attacks against enemy networks, shutting down command and control systems from the air. Directed energy weapons, once only in science fiction, are becoming real for sixth-generation planes. These include high-power microwave weapons and lasers. Microwave weapons can be used to overload and permanently disable the electronics of enemy aircraft, drones, and missiles without causing a physical explosion. This offers a way to achieve a soft kill without hitting anything. Lasers can be used for defense, precisely shooting down incoming missiles at the speed of light. They can also be used for attacking, blinding enemy sensors, or even precisely damaging important parts of an enemy aircraft, giving a new set of tools for air combat. Beyond these main technologies, sixth-generation fighters will also have other advancements. This includes advanced materials and heat management systems to help hide the aircraft's heat signature from infrared sensors, making it even stealthier. They will have super strong connections, using laser communication and advanced data links to share huge amounts of data safely and instantly with the wider network. The cockpit, if there is one, will likely have a wide screen and an augmented reality helmet that makes the pilot feel fully immersed in a digital view of the battle space. All these systems will be powered by artificial intelligence to handle the huge complexity and allow for split-second decisions. Several countries are actively working on sixth-generation fighter jets, which shows a new global arms race for air power. The United States is leading the way with two main programs. The U.S. Air Force's Next Generation Air Dominance program is probably the most well-known. This isn't just one fighter jet, but a whole family of systems, including a piloted combat plane, unmanned helpers, advanced weapons, and a secure data network. A full-size prototype for the NGAD platform has already flown, proving that the main ideas work. The U.S. Navy also has its own program, also called NGAD, but often known as F/AX, to develop a carrier-based replacement for the F/A-18E/F Super Hornet. In Europe, many countries are working together to create a complete sixth-generation system. The Future Combat Air System, also known by its French acronym SCAF, is a joint project led by France, Germany, and Spain. Like the American NGAD, FCAS is also thought of as a system of systems. This system will have a next-generation fighter at its center, working with unmanned, remote carriers, all linked by a complex combat cloud network. The goal of this program is to make sure Europe stays in charge and leads in aerospace technology for decades to come, with the system planned to be ready around 2040. The UK, along with its partners Italy and Japan, is working on its own sixth-generation program called the Global Combat Air Program. The main part of this effort is the Tempest fighter jet. Like its counterparts, the Tempest will have a cockpit that can be optionally manned, advanced communication systems that can be changed, and directed energy weapons. A big focus for the GCAP program is fast development, digital engineering, and being cost-effective, using advanced manufacturing techniques and open system architecture to make sure the fighter can be quickly and cheaply upgraded throughout its service life. Working with Japan shows a big shift in global politics, bringing together key partners in Europe and Asia. Developing these planes is super important for keeping our technology ahead and making sure our country is safe in the future. The technologies being created for these programs, from AI and self-operating systems to adaptive engines and directed energy, will have effects far beyond just military planes. They will drive new ideas in the aerospace, computer, and manufacturing industries. As the competition between big powers gets stronger, countries that successfully use these next-generation air combat systems will have a clear advantage. They will be able to show their power, stop attacks, and control the skies in any future fights, shaping how things work in the 21st century.